All right, so this is going to be a video about solving quadratic equations with complex solutions. And so what I did here is I have 5 example problems right here. Some of them, actually most of them, have complex solutions. A couple of them do not. I did that on purpose to kind of show you what the difference is between equations that have complex solutions and the ones that have a real solution. So hopefully that makes more sense. All right, so this first one, it says x squared plus 4x plus 5. So the first thing I'm gonna do to solve this problem, so we're just looking for the solutions, is use quadratic formula. And that's just kind of a good rule of thumb to follow, is like always, first thing you should do is just try to do quadratic formula, because it's the one way when you try to solve these problems where you're always going to get the right solution if you actually use the quadratic formula correctly. Okay. Yes, you can factor. Yes, you can graph, but sometimes those don't actually lead to any solutions. You could also complete the square if you want, but for the most part, the easiest way of doing this is using quadratic formula. So I highly advise doing it that way. All right, so quadratic formula is going to be x equals negative b, which in this case, b is equal to 4. So it's going to be negative 4 plus or minus the square root of b squared, which is 16, minus 4ac. So 4 times 1, because a is 1 here, times c, which is 5, is going to be 20 here. Okay, we're doing the square root of that here. And then we're dividing this by 2a, which is just going to be 2 times 1, which is 2. Now, hopefully you see the issue with this right away is the fact that you have this 16 minus 20. So you're technically doing the square root of a negative number there, which means that you are going to need imaginary numbers to solve this problem out. So first thing we're going to do is I'm going to rewrite this, only this time I'm going to write the square root of negative 4, and we're still dividing by 2. Now this square root of negative 4, what you can do is you can factor out the I. So it's going to be negative 4 plus or minus, I'm going to take the I out, and then it's just going to be times the square root of 4, and then we're dividing this by 2. Well, the square root of 4, that's a perfect square. 4 is a perfect square, so the square root of 4 is just going to be 2. And what you can do is divide the top and the bottom by 2 here, and you end up with negative 2 plus or minus this 2. If you're dividing the top by 2, you also have to divide that by this 2 right here by 2. So it's going to be just I, and then divided by 1. We don't really need to write divided by 1. So essentially what I did is I divided the top part here by 2, and then I divided the bottom part by 2. Okay, so when I did that, this became negative 2. This 2 canceled out, and then 2 over 2 is 1. I'm not going to write divided by 1 here because it is pointless. So anyway, that ends up being the final answer right there. Now, what you can do if you wanted is you can take that answer and plug it in for x for the original equation here, and you should get 0. Now, if you are allowed to use your calculator on problems like these, I highly advise doing it this way. I'm going to kind of show you right now just so this kind of makes more sense, and then you can kind of do it on all the other ones to make sure that they work. All right, so first thing I'm going to do is I'm going to store my solutions, that negative plus or minus I, that negative 2 plus or minus I, I'm going to store that in for x. So I'm going to do the plus first because the calculator can only do one solution at a time. So I'm going to say negative 2 plus I, and I'm going to store it by clicking the STO button right here, STO, and I'm going to store that in for x. So now what you can do is you can plug that, using that original equation, that x squared plus 4x plus 5, what you can do is just write x squared plus 4x plus 5. Now you should technically get 0 if your x is the right solution, so you hit enter and you do get 0. So that actually proves that negative 2 plus I is one of the solutions. But you also need to test the other solution. So instead of negative 2 plus I, we're going to do negative 2 minus I. And again, we're going to do the same thing of just storing that in for x. Okay, and then I'm going to redo that expression that I had before, the x squared plus 4x plus 5. And then if I solve this out, we should also get 0 if we have the correct solutions, which we get 0. So you know that this actually does work out. So what I like to do sometimes is when I check with my calculator, I'll put a little check by it, meaning that I actually did check my work to get that right answer. All right, let's go to the next one. All right, so for this one, again, we're going to use quadratic formula. So we're going to end up having x is equal to negative b, which is negative 6, plus or minus the square root of b squared, which is 36, minus 4ac, which is just going to be 20 in this case. and then we're dividing all of this by 2a, which is 2 times 1, so you just get a 2 here. Now, one thing that I do want you to notice on this problem is we have the square root of a positive number. Okay, so because of that, if we have the square root of a positive number like that, there will be no complex solutions. Okay, there's not going to be any I in this problem, so that means there aren't going to be any complex solutions. The way this works, this was discussed in a previous video, but your solutions can either be 2 complex solutions, 2 real solutions, or 1 real solution, essentially. Okay. And another way of looking at that, because technically complex solutions are real solutions, you can have 2 reals that are pure real numbers, like pure meaning there is no imaginary part to it, or you can have 2 that has an imaginary part to it, or you can have 1 that just has a pure real number to it. Okay, it'll make more sense as we go. But this one should have no complex solutions because there's not going to be any I in it. This ends up being -6 plus or minus the square root of 16 all over 2. Okay, well this becomes 4. So you end up with 2 solutions here of -6 plus 4 over 2 and -6 minus 4 over 2. Okay, we do need to simplify both of these. So at the very top here, we're going to have -2 over 2, which is -1. Over here, we're going to have -10. I'll do -10 over 2, which is -5, and you have your 2 solutions to these right here. Now, again, if you wanted, you could actually still throw these in the calculator and see if they work. So that's what I'm actually going to do right now. So this time I'm going to put -1 as my x, and then store it in like that. And then I'm going to do x squared plus 6x plus 5. Hit enter on that, and you do end up getting 0, which is what we want. And then I'm going to do -5, store that in for x. Okay, I'm going to go grab this original expression right here, hit enter on this. Again, you get 0, so you know that both of these check out by using your calculator. Okay. All right, onward. All right, for this one, we have x squared minus 2x is equal to -1. The reason I put this problem on there is because you have to know that, because you have to put the equation in standard form to be able to use quadratic formula. So what I'm going to do is add the 1 to the other side, so you end up with something like this. Okay, now it is in standard form. We know what the a is, we know what the b is, we know what the c is for that quadratic expression. X is going to be equal to -b, which is just going to be 2, because it's -2. Plus or minus the square root of b squared, which is 4, minus 4ac, which is 4 times 1 times 1, which is just 4. And then we're dividing all of this by 2. Now, an interesting thing about this one is that you're doing the square root of a 0. So essentially this whole thing right here goes away, because this is equal to 0. It says 2 plus or minus 0. Well, 2 plus 0 is the same as 2 minus 0. So you end up with just 2 over 2 here, which is equal to 1. Okay? So in this case, you have a real solution, a pure real solution, and it ends up just having 1 answer. Now, really, this has a multiplicity of 2, but just know that there is 1 solution to this, but technically it has a multiplicity of 2. And the reason for that is based on the fundamental theorem of algebra. Right here, this polynomial has a power of 2. The highest power is a 2. Now, since this is a polynomial and the highest power is 2, that means there should be technically 2 answers. Well, there's only really 1 answer for this one, so you would just say the answer is equal to 1 multiplicity 2. Okay. Now, if you compare that concept to other things we've done over here, this one, if you notice, it says no complex solutions, but you end up with 2 real solutions, purely real solutions. Now, since there is a 2 here, because it's quadratic, you should have 2 solutions like we do right there. And then going to that first one, we have -2 plus I, and we have -2 minus I. That's 2 solutions. Again, it follows the fundamental theorem of algebra based on this polynomial. The highest power that it has, the degree of that polynomial, is going to tell you how many answers you should have. Okay. Again, sometimes the answer is just really 1, but it has a multiplicity of 2. Okay, this one right here, we have x squared plus 10 is equal to 3x. So this is similar to the last one we did, in which you have to put it into standard form. So I'm gonna minus 3x from both sides. So this 3x goes to the other side. Essentially, plus 10 is equal to 0. One thing I just remembered is if you want, you can check this as well on the calculator. I'm kind of skipping that step for now, otherwise this video is going to be too long, but highly advise checking that yourself. Okay, from here we're going to use quadratic formula, so it's going to be x is equal to negative b, which is 3, plus or minus, because it's negative, that's why it's positive, plus or minus the square root of b squared, which is 9, minus 4ac, which is just going to be 40. And we're dividing all of this by 2 times 1, which is just 2. Now right away you should see that you're going to end up with complex solutions here. In this case, you're going to have 2 complex solutions because it's got that plus or minus right there that makes it so you have 2. So I'm going to simplify this out really quick. And you end up with something like this. Now from here, if you notice, it looks like it's simplified, but you can't have the negative in the square root like that, underneath the square root like that. So we're going to do 3 plus or minus. We're going to pull that I out. So now that negative 31 becomes positive 31, and then we're still dividing it by 2. And you end up with your final answer to be 3 plus or minus, so that means there's 2 answers there, I root 31 over 2. Again, make sure you use your calculator to check that. All right, the last one right here, we have 4x squared plus 100, so it is in standard form. But what I'm gonna do first here to solve this equation is I'm actually gonna factor out the 4. It makes my life a little bit easier if I do it this way. Okay. Now since this is equal to 0 on the other side, I'm going to divide both sides by 4 just to get rid of this 4 right here. And you end up with x squared plus 25 is equal to 0 over 4 is still 0, so I'm just going to write 0 there. Now if we wanted, we could have just done quadratic formula right away, but this one actually doesn't have a b term, so it's a lot easier just to kind of solve on our own. So what we're going to do is subtract off that 25 to the other side. So 0 minus 25 is negative 25. And then we're going to do the square root of both sides, and square root it. You also have to caboot it with the plus or minus. Okay. So then this cancels here, so you end up with x is equal to plus or minus the square root of negative 25. So what I'm going to do is actually pull the I out of that and then just write the square root of 25. Obviously this simplifies because the square root of 25 is 5. So your final answer ends up being plus or minus 5i. Okay. If you notice, we still do have 2 answers, which we should, based on the fundamental theorem of algebra, have 2 answers. And again, if I were you, I would check that by putting that plus or minus 5i into the original equation. And use your calculator to see if you actually got that right. So that's a video on solving quadratic equations with complex solutions. If you have any questions about anything in this video, let me know.